Having standard functions in your toolkit can make things so easy sometimes. So just like in this integral, if you have idea about the Digamma function, right, some of its standard values or its infinite series formula, then like this integral actually becomes so easy and straightforward. So let me show you how. So there's this integral from 0 to infinity of e to the power minus x ln square x dx, right? This might remind you of the integral for gamma function actually, because gamma of n is this integral from 0 to infinity of e to the power minus x to the power n minus 1 dx, right? Now, if you actually like differentiate this integral twice with respect to n, so what you basically get is what you get over here is like if you differentiate it twice, you will have integral from 0 to infinity of e to the power minus x and then x to the power n minus 1. If you differentiate once, there will be ln x. If you do it twice, there will be ln square x, right? And then dx. Now over here, notice that if like I evaluate this at n equals to 1, this x to the power n minus 1 will just go to x to the power 0. So this is basically the same integral, e to the power minus x ln square x dx. So we realize that this thing over here, like this over here is just the second derivative of gamma of n at n equals to 1, right? So this integral over here is also the second derivative with respect to n of, sorry guys, that was 11 11. I set an alarm for that, I'm sorry. Okay, um gamma of n equals to 1. So now, okay, so now you have to take second derivative of the gamma function and evaluate that at n equals to 1, right? And that will basically be our answer. So let's do that. So if you just differentiate this gamma function once, we will have gamma prime of n, right? And now, like like we can actually write gamma prime in terms of gamma and digamma, and uh the formula is basically gamma prime of n is equals to gamma of n times digamma of n. Okay, and if you like in digamma of n like is it's like minus well imaginary constant. Um, let me write this as n plus 1 plus nth harmonic number. And if you want to write nth harmonic number as infinite sum, you can write it as sum from k equals to 0 to infinity of, sorry, from 1 to infinity of 1 by k minus 1 by k plus n. Okay, so this is the digamma function. Let me also tell you about trigamma function right now because it will be necessary later on. You just have to differentiate digamma and you get trigamma. If you differentiate with respect to n, you get trigamma to be equals to, because this is constant now, goes to 0. 1 by k also constant goes to 0 because we are differentiating with respect to n, so this becomes 1 by k plus n square. Okay, you should know about these things, right? And so over here, so back to our context, this gamma prime is just gamma function times digamma function, right? And now, after that, what you can basically do is again differentiation product rule. So you will have gamma of n, derivative of digamma is just trigamma, plus now gamma prime of n and digamma just as it is, right? And whole thing at n equals to 1. Okay, so over here, this becomes, so again, I can write gamma prime as gamma times digamma function, right? So there are now two digammas over here. This whole thing at n equals to 1. So I can actually take gamma function common, and then I will have trigamma function plus digamma function square, right? Whole thing at n equals to 1. We now notice that at 1, this becomes gamma of 1, and then trigamma of 1 plus digamma of 1 square, right? Gamma of 1 is just 1. Now from here you can find that trigamma of 1, you have substitute n as 0, and that basically gives zeta of 2 over here, which is pi square by 6, right? So similarly, if substitute n as 0 in the digamma function like thing over here, you get digamma of 1 as minus over Masonic constant, and these two terms now become same because n is 0, so they cancel out, and you just have minus over Masonic constant. So now that you have those two values, this just becomes pi squared by 6 plus minus over Masonic constant is squared, and this becomes over Masonic constant is squared plus pi squared by 6. And that is a beautiful answer. Okay, so over here, knowing the fact that this digamma function, its properties, and also this like gamma prime function, its properties, and then like how to find their special values, that just made this integral so easy. Otherwise, it could have been such a difficult like thing to do. So that's what I'm telling you guys. Like definitely, I think it's helpful to know like different kind of special functions and how to make manipulations with them and like things like that. It can come really handy sometimes. So that's for today, guys. I hope you enjoyed this video, and I look forward to seeing you in the upcoming video too.